in this particular chapter of ratio and proportions, there are 4 or 5 very standard concepts which you need to learn and which would be applied across all the chapters. No matter what chapter you deal with, you will definitely find the application of ratio and proportion everywhere. And again, this is one of the most fundamental chapters that you would ever encounter. Okay, so be ready and be very, very aware about whatever I'm teaching. Please note down the things that are required and re-watch the video if you don't understand any point, and you can leave your doubt in the comment section and we would definitely get back to you. So what basically ratio means is that we are comparing quantities, we are comparing quantities by division. Okay, when I say that I need to compare two quantities and I'll be using a ratio for them, so for comparing two quantities we will use this sign. This sign is called a colon sign. Okay, this is called a colon sign and it would be represented in the form of a by b. The next thing which you need to keep in mind is that a and b should have the same units. Okay, the same units. When I say units, let me give you an example. Let's say that 500 kg is being compared by 10,000 grams. So this ratio cannot be established unless both the quantities are brought to the same unit. And as you can see that kg and grams are not the same unit, what you can do is you can convert the grams side into kgs. So 1,000 grams make up 1 kg. So 10,000 grams are going to make up 10 kg. Simply you can convert this entire situation to 500 kg versus 10 kg. Okay, the kg and the kg would get cancelled, 1 0 is gone with 1 0, so 50:1 is the ratio. Okay, 50:1 is the ratio. Then there is something called inverse ratio. Whenever I have a straight ratio, it is called a is to b and it is represented by a upon b. And whenever I am talking about inverse ratios, then this thing converts itself into b is to a and it would then be represented by b upon a. We are doing nothing but we are interchanging the sides. Okay, interchanging the things in the numerator and the denominator. So this would come out to be, when I multiply the ratio with the inverse ratio, this is a straight ratio, when I multiply it by inverse ratio, it would always come out to be 1. Okay, this thing is something that is a very standard point and you must remember it. Okay, so there are 3 or 4 things that we learned on this particular slide. The first one being that ratios are nothing but comparing quantities with the help of division. Secondly, the units should be same. The units or the dimensions, I rather say, the dimensions must be the same. And once the dimensions are same and the units are same, then we can compare them. Then there is a concept of inverse ratio, and inverse ratio is nothing but the reciprocal of the straight ratio. Okay, we'll be going to the question and we'll be taking up the other standard points in the upcoming slides. Let me delete all this. This is, I was just checking. Okay, so here goes the first question. A number is divided into 3 parts which are split in the ratio 3:4:5 and the sum of their squares is 5,000. Find the 3 parts. So firstly, whenever we are studying ratios, there is a very cool thing which you must remember. What people usually do is that they try to assume that x is the common factor between the ratios. X is the common factor between the ratios which got cancelled. Hence, if you wish to have absolute values, if you wish to have absolute values, you must multiply by x. Okay, so what they'll teach you is that 3x is the absolute value of something which was sitting in the ratio of 3 is to 4 is to 5. Similarly, 4x was the value, and similarly 5x was the value. Okay, remember this. This is value and this is ratio. Value is in absolute terms, ratio is in proportion terms. Okay, it means it is being compared with everything else. So we would not follow this particular situation. We would follow the use of x only when it is necessarily required. Okay, when there is no other way to come out of it, at that time we would use x, else we would use the ratio straight away, and we will assume that the ratios are the absolute value. Okay, so let's assume there are three numbers, 3, 4 and 5. The sum of their squares in real term or in absolute value is 5000. These are the ratios of the numbers. We need to first find out the squares of the numbers. Okay, let's assume that this is x. I'm not going to use it, I'm just showing it to you. And this is x square. 3 square is 9, 4 square is 16, and 5 square is 25. It says the sum of all these is equal to 5000. What is the actual sum of 9 plus 16 plus 25? It is equal to 50. It is equal to 50. So the value of 50 corresponds to 5000. I cancel it out at 1 and then 100. Now the value of 1 which we are getting is equal to 100, and this 100 was a proportion of squared values. How do I come to this conclusion? It has been written over here that the sum of their squares. That's why it was a proportion of squared values. So I would have to take a root of it. Why am I taking a root of it? Because the root of 10 which I get, the root of 100 equal to 10 which I get, this is basically the x that we were talking about all the time. Okay, this is basically the common factor which was eradicated when the ratio came to the point. So the original values or the original parts can simply be represented by 3 is to 4 is to 5 at the beginning of the question, and this number which came out, which is equal to 1 unit, we will have to multiply it with here with all the ratios. So the three parts come out to be 30, 40 and 50. Okay, so this is my final answer, that the three parts are 30, 40 and 50. So what did we learn from this portion? We learned that the values are used are brought into the picture using x. Okay, x is nothing but the absolute but a common factor which got cancelled out when ratios came into the picture. And if I wish to get the absolute value back, I will have to multiply x with it. Okay, I will have to multiply the x with the ratio. Then secondly, if you've already checked the proportion and it is that of a squared value, you will have to take a root of it so as to bring it down to the ground or bring it down to the first power, because the entire question was being solved in second power. Okay, so original part would be multiplied by the root of 100, which is 10, and 1 unit would be equal to 10. 3 is to 4 is to 5 would be 30, 40 and 50. Moving to the next question. Then there is another standard point of ratio which I would like to tell you about. Whenever two ratios are given, A is to B, and a third ratio is also given, B is to C. Let's assume the value here is 2 is to 3, and the value here is 7 is to 11. Okay, so when I am and the examiner asks me what is the value of A is to B is to C. So what am I supposed to do here? I would write it in this manner, A, B, C. Then I would write 2 is to 3 because this is the first ratio. And I would write the second ratio over here, 7 upon 7 is to 11. This 7 would come here as 7. This 3 would come here as 3. Okay. You have to shift the numbers to their empty slots. And then I have to multiply them. Okay. 2 sevens are 14. Ratio 3 sevens are 21. Ratio 3 elevens are 33. Okay, so I hope you've understood my technique of getting the biggest ratio out of the particle ratios. Okay, I'm calling these two ratios as smaller ratios, and this I'm calling as the parent ratio. Okay, or the biggest ratio of them all. Moving on, it says that A is to B is equal to 2 by 3. Then what is the value of 5A plus 3B whole upon 6A minus 2B? In such a question, people will again advise you to write the absolute values as 2x and 3x. In the end, the x would get cancelled, but I don't really think it will be helpful to you in the long run. What you should do is you should assume that the absolute value of 2 is of a is equal to 2, and you should assume that the absolute value of b is equal to 3. Once this assumption is made in place, you can directly fill in the values over here. Using a is equal to 2 and b is equal to 3, I would write 5 into 2 plus 3 into 3 whole upon 6 into 2 minus 2 into 3. Okay, so solving the numerator first, 5 2s are 10, 3 plus 3, 9. Solving for denominator, 6 2s are 12 minus 3 2s are 6. So it's going to be 19 upon 6. And this is my answer. I'll help you solve it with the help of X as well, but I'll show it to you with a blue pen. Okay. This solution with X is for those students who really like to use X. I am not denying that X is not useful. X is definitely useful, but as you grow to the advanced side, you would learn that the use of X is not very, very necessary. Okay. So again, solving the question, A by B is equal to 2 by 3. For using the absolute values, I would consider that the absolute value of A is 2x and the absolute value of B is equal to 3x. Okay, 2x and 3x. Then putting it in the question itself, 5 multiplied by 2x plus 3 multiplied by 3x whole divided by 6 multiplied by 2x minus 2 multiplied by 3x. Okay. So once I solve it, I would get the value as 19x upon 6x, and the x would also get cancelled off. So the final answer would come out to be 19 upon 6. Okay, the answer would come out to be 19 upon 6. And I hope you understand how I solved the question with the help of x as well. Okay, moving on. 700 is to be divided among A is to B is to C in the ratio of 1 by 2, 1 by 3 and 1 by 4. How much share will B get? Always remember one thing. When the ratio of A is to B is to C is written, then if this ratio is equal to X is to Y is to, just a second, if this ratio is equal to x is to y is to z, x is to y is to z, at that time we can assume that directly the value of a is proportional to x, the value of b is proportional to y, and the value of c is proportional to z. Okay, but if in any case it is written that a is to b is to c is equal to 1 upon x is to 1 upon y is to 1 upon z, at that moment we cannot assume that the value of a or the value of b or the value of c is directly x, y, and z. There is a reason to it, and the reason is that these are inverse ratios. You first need to you first need to have an LCM of them, and then repopulate the numerators, and then you'll get the absolute value. So what do I do to do that? I need all the ratios to be only in the numerator. For that, I would take an LCM of x, y, z, which is automatically equal to x, y, z, and I would multiply them with the ratios available. X, y, z multiplied by z, x, y multiplied by x, y, z. Okay. This is nothing but a silly mistake of writing x, y, z as z, x, y. Need not bother about it. Then I have divided it by x, and then divided it by y, and divided it by z. Or to be more simple, I have multiplied it by 1 by x, and multiplied this by 1 by y, and multiplied this by 1 by z. Now, do the cancellation, do the relevant cancellations. I've cancelled x, I'll be cancelling y, and now I've cancelled z. So the output would come out to be yz is to xz is to xy. Okay. So I have these calculations in front of me. Now you can say that the absolute value of a is equal to yz, the absolute value of b is equal to xz, and the absolute value of c is equal to xy. Okay, all right. The absolute value of c is equal to xy. So this is why we are here, and this is how it comes out to be. There is another method to solve this. I'll show you that method as well. If at all somebody tells you that a upon x is equal to b upon y is equal to c upon z, if this situation comes up, then you can easily assume that a's value is x, b's value is y, and c's value is z. Okay, this is the third way. This was the first standard form, this was the second reciprocal form, and this is another third standard form. Okay, these can be assumed to be their absolute values as well. Then this thing has been solved on the right hand side. Yeah, then there is a method which is called the hide and seek method. There is a hide and seek method which is applicable to the second method also. A is to b is to c has been given as 1 by x is to 1 by y is to 1 by z. So what you will do is that, as when you need the value of y, you would when you need the value of a, you would hide the value of 1 by x and multiply the denominators of y and z. Okay, or multiply the denominators and of b and c. So you will directly get the value of a as yz. Similarly, if you wish to find out the value of b, you hide y 1 upon y with your hand and multiply x with z, which gives you xz. Then if you wish to get the value of c, you can hide z with your palm and focus only on xy, which would be your value for c. Okay, which would be your value of c. So now I'll be solving the question which is given here. The question says that 7800 rupees have to be divided among a is to b is to c in the ratio 1 by 2, 1 by 3, and 1 by 4. So I'll use the hide and seek method and find the absolute value of a. The absolute value of a B, and C would be hiding 1 by 2 and multiplying 3 by 4, which is equal to 12. Similarly, hiding 1 by 3 and multiplying 4 and 2, which is 8. Hiding 1 by 4 and multiplying 3 into 2 is 6. Okay, so 2 6 are 12, 2 4s are 8, and 2 3s are 6. So 6 is to 4 is to 3 is the ratio between A, B, and C. Now it says that rupees 7800 is the total value of everything. So what would be the share of B? The share of B is 4 out of a total of 13. 13 ones are 13, 6 are 78, 600. 4 when multiplied by 600 would give me 2400. And this is my final answer. Alright, moving on. The compound ratio of 3 is to 4 and 6 is to 7 is 36 is to x. When I talk about compound ratio means multiplication of ratios. Multiplication of ratios. So 3 is to 4 would be multiplied by 6 is to 7. And the value of this is equal to 36 upon x. And now I need to find out the value of x. Okay. So 6 3s are 18. 18 and this becomes 2. So the value of this comes out to be 7 8s are 56. Okay. So the value of x is nothing but 56. I hope there was nothing complicated in this. Okay. Compound ratio means multiplication of two or more ratios. Okay. Multiplication of two or more ratios. Moving on. Now, there comes a time when multiple ratios are given together. I've already taught you about componendo and dividendo. So this is a little similar to that, not completely similar, but little similar to that. What I would like to talk to you about is whenever there is an equation that x upon y is equal to a upon b, and I apply c and d to it, or componendo and dividendo to it, I can easily write that x plus y upon x minus y is equal to a plus b upon a minus b. So what this concept is talking to me about is that whenever you encounter this situation with you, then you can easily split the situation back to its original form, which is equal to x upon y is equal to a upon b. That is it. Okay, this is nothing but reverse engineering of whatever we have studied till now in componendo and dividendo. Moving ahead with the question, 5a minus 3b upon 4a minus 2b is equal to 2 by 3. Okay, is equal to 2 by 3. So 5a minus 3b whole upon 4a minus 2b is equal to 2 by 3. So doing the cross multiplication, this would go here, this would go here. 2 4s are 8, a minus 4b is equal to 3 5s are 15a minus 9b. Okay, so taking it here, 7a is equal to 5b. So the value of a upon b is equal to 7 upon 5, or 7 is to 5, which is my final answer. Okay, moving on. Sorry. Now in this case, we can easily use componendo and dividendo, because whatever is in proportion, they are of equal magnitude. When I say equal magnitude, what do I mean? I mean that 7x plus y whole upon 7x minus y is equal to 7 upon 3. sorry sorry 7x plus y whole upon 7x minus y is equal to 7 upon 3. So both the terms are the same in the numerator as well as in the denominator, just the signs are opposite to each other. So I can easily write that 7x upon y is equal to 7 plus 3 10, and 7 minus 3 4. Okay, So the value of x upon y that I can see over here is 2 2s are 4 and 2 5s are 10. So the answer to this question is 5 upon 14, or 5 is to 14. Okay, the answer to this question is 5 is to 14. Moving on, there can be times when a number is divided into multiple parts. We've already seen that in the first or the second question. Now we'll be seeing it in three parts in the upcoming question. Okay, now see this. If 9685 is divided into three parts such that 1/4 of the first part, 1/3 of the second part, and 1/6 of the third part are equal, then what is the first part? In this property, I'll just show it to you. In this property, I've told you, if the ratios come in this format, then the absolute values are x, y, and z respectively of a, b, and c. So we'll be using this property number 3 in our question over here. Okay, it says 1/4 of the first part. This means, let's assume the first part is a, the second part is b, and the third part is c. So 1/4 of the first part, this means a upon 4. 1/3 of the second part, 1/3 of the second part, this means b upon 3. And 1/6 of the third part, this means c upon 6. So all these are equal and they all sum up to 9685. They all sum up to 9685. So we can easily assume that the absolute value of a is 4, b is 3, and c is equal to 6. So when I add all of them up, this comes out to be 13. The value of 13 has been given equal to 9685. And they have asked us what is the first part. The value of the first part is in proportion to 4. So I would say 4 would be multiplied by 9685 whole divided by 13. How did I come to this conclusion? If the value of 13 is equal to 9685, then the value of 1 would be equal to 9685 whole upon 13, and the value of 4 has been asked to me. So 4 would be proportional to 4 multiplied by 9685 whole upon 13. So I'll use the table of 13. 13 ones are 13, 13 sevens are 91, then 58, 13 threes are 13 fours are 52, then 13 fives are 65. So I have 745 multiplied by 4, which is equal to 4 fives are 20, 4 fours are 16, 17, 18, 1 4 sevens are 28, 2980. So the portion of A in 9685 is equal to 2980. Are we good? I think we are. Okay. So moving on to the next question. A sum of 1180 is to be divided among A, B, and C such that 2 times the share of A, 5 times the share of B, and 7 times the share of B are equal. I will write the equation. 2 times A is equal to 5 times B is equal to 7 times C. Okay. When all of this is equal, the 1180 was divided in such a way. These are the coefficients. We can prove all of them to be equal only and only when they are in the numerator, when they are in the denominator. So what would I do? I would take the LCM of 2, 5, and 7. The LCM of 2, 5, and 7 is 70. Yep, 70 is good. And I would divide it across the three options. So 2a by 70, 5b by 70, and 7c by 70. So the value here is a upon 35 is equal to b upon 14 is equal to c upon 10. Now it has been given that 35 plus 10, 35 plus 14 plus 10, which is equal to 59, is equal to 1180. 0. Okay. One step that we missed was, I forgot to tell you that we can assume that now the value of A, absolute value of A is 35. We can assume the absolute value of B being 14 and the absolute value of C being 10. So 59 is equal to 1180. So the value of 1 would be 1180 upon 59, and the value of 35 would be 35 multiplied by 1180 whole upon 59. 59 ones are and 59 20s are 118. 35 and 21 multiplied give me 70, and there's another 0. So the share of A comes out to be 700. Okay. The share of A comes out to be 700 out of a total of 1180. I think we're good. So let's move on. When 2p, 3q, and 4r and 5s are equal, what is the value of p, q, r, and s in terms of ratios? Okay, I'll write it down again. 2p, 3q, 4r, and 5s. I'll quickly take an LCM of 2, 3, 4, and 5, which gives me the LCM as 5 4s are 20, 23 is a 60, 60, yeah. So I think 60 is the LCM, and I would divide all of them by 60. 2p upon 60 is equal to 3q upon 60 is equal to 4r upon 60 is equal to 5s upon 60. Okay, so cancelled out as 30, cancelled out as 20, cancelled out as 15, and cancelled out as 12. So 30, 20, 15, and 12 is the ratio, and 30, 20, 15, 12. So this is my answer: 30, 20, 15, 12. You could have also gone for the hide and seek method, like for the coefficient of for the ratio of p. You could have hidden the p and multiplied all the other coefficients. 3 into 4 12, 12 plus 5 60. You could have directly written that 60 is the coefficient. Then in the due process, they would have gotten cancelled, and 30, 20, and 15 and 12 would have prevailed. Okay, they would have prevailed means they would have stayed there, right? So moving on to the next question. Yep. So I have already taught you when A is to B is given as a separate ratio, and again B is to C is given as a separate ratio. At that time, you have to apply a little bit of shifting here and here, and then you have to multiply all of them, and that's when you get your final answer out. Okay, let me go take you to the question directly. If the sum of three numbers is 98, then and the ratio, if the ratio of the first to the second is 2 is to 3, and that of the second to the third is 5 is to 8, then tell what is the third number. So what it is trying to tell us is A is to B is given, and B is to C is given, and you have to find out the value of C. Sorry, A is to B is given as 2 is to 3, B is to C is given as 5 is to 8. Let me put all of them in order. 2 is to 3 and 5 is to 8. Now they are in order, and they are the values of A is to B is to C. Shifting it over here as 5, shifting this over here as 3. Quietly putting a multiplication sign. 2 5s are 10, and another 5 3s are 15, and another 3 8s are 24. So 10 is to 15 is to 24 is equal to the ratios between the three numbers, and the sum of all of it is equal to 98. Then the third number is, if the sum of all of them, which is equal to 49, yeah, it's 49, yeah. So the if 49 is equal to 98, then the third number, which is 24, would be equal to what? To make 98, 49 had to be multiplied by 2. To make out the value of 24, we need to multiply it by 2, and the final outcome would be 48. Okay, I hope that's good. I hope that's very, very good. Let's move on. Divide 1488 among x, y, and z, and if the shares are x is to y 4 is to 5 and y is to z is 7 is to 6, then find the share of z. Okay, I'm again going to write them in that manner: x, y, y, z. This is 4 is to 5 and this is 7 is to 6. I'll write them in proportion: 4, 5, 7, and 6. The 5 moves here and the 7 moves here, and this is the value of x, this is the value of y, and this is the value of z. 7 4s are 28, 7 5s are 35, and 5 6s are 30. So this is the proportion. If all of them sum up to be 13, okay, this is 5 and this is 13, there's 1 3 3 6, 6 plus 2 8, 8 plus 1 9. So the value of 93 is 1488. Then the value of 30, which is also the value of z, needs to be found out. 1488 upon 93 into 30. 3 10s are 3 3s are 9, 3 1s are 3. Okay, so 31 1s are, I believe this is 31 4s are, and in the end the unit digit is 8, so I'm assuming that it would get cancelled at 8. And we also have 480 in the option, and I really got excited about it, that 480 is our correct answer, and that is what we are getting. All right, so I'll be moving to the next question. There is a good possibility that the proportion which we've seen in the past were only A, B, and BC. There is a good possibility that in the upcoming questions we would find AB, BC, and CD. So when such thing is encountered, C would shift here 2 times, B would shift here once, B would shift here 2 times, and C would shift here once. And all these numbers would be multiplied in this fashion. Okay, I hope it is clear to all of you that how this shifting is going to work and how we are going to multiply things. Let me take you directly to the question. If AB, BC, and CD are given in proportion, then what is the value of A is to D? Let me skip a step and help you with all of them together. If the value of AB is 5 is to 4, the value of BC is equal to 6 is to 5, 6 is to 5, and the value of CD is equal to 7 is to 10, then simply we need to pluck out the values of A and B. Okay, we'll pluck out the values of A and B directly. 4 would be shifting here on the right 2 times, 5 would be shifting on the right to its empty space, that is 5 again. 7 would be shifting here twice, 7 here as well, and here as well. 6 would be shifting once to the left hand side. Now the value of A is equal to 5 into 6 into 7. The value of D is equal to 4 into 5 into 10. So they need to be divided as A upon D, or A is to D has been asked. So A is to D is equal to 5 into 6 into 7 whole upon 4 into 5 into 10. The 5 and 5 get cancelled. This is 2 3s are 6. This is 2 5s are 10. Then 21 upon 20 is my answer. Okay, I hope everybody is pretty satisfied with it. Moving to the next question. 2p 3q and q 5q 4r. Okay, and pqr needs to be decided. From the equation 2p is equal to 3q, I decide that they must go in the denominators to be useful. P upon 3 is equal to Q upon 2. Similarly, 5Q is equal to 4R. So moving these in the denominators, Q upon 4 is equal to R upon 5. So now I can easily see that I have the absolute value of P as 3, Q as 2, here Q as 4 and here R as 5. So what I'll do is I'll write them down in this fashion, which I've already been doing, and I'll straight away write it down like this. 4 shifts to left, 2 shifts to right, and this is my answer. 3 fours are 12, 4 twos are 8, and 5 twos are 10. There is a common value of 2 over here. So 2 6 are 12, 2 4s are 8, and 2 5s are 10. So this is my P is to Q is to R. 6 is to 4 is to 5. Cool. I think we are really good. Now, in the upcoming questions, we would have a sum with us. A sum means the total money we have, and most probably our grandmother or our parents or somebody else would have given us that money in coins or notes. Okay, coins or notes. The ratio, the value of the coins, and the ratio. Ratio means the number of coins. Okay, the ratio between the coins would be given. If you multiply the value of the coin with the ratio, then we get the total sum. And this is the main point which you need to remember, that when you multiply the value with the ratio, that is when you get the total sum of the coins or the notes or any sort of currency based questions. Moving to the first question. Atul purchased bread costing rupees 20 and he gave a note of 10 rupees to the shopkeeper. The shopkeeper gave the balance money in coins of the denominations 2, 5 and 10. Firstly, you need to tell me what the balance money is. The balance money here is 100 minus 20, which is equal to 80. 100 was the total amount that he gave, 20 was the bread that he took home. So 80 is the balance amount, which was split into 2, 5 and 10 rupee notes or coins. If these coins are in the ratio 5 is to 4 is to 1, okay, so this is the value side and this is the quantity side. Okay, the value side and the quantity side. And how many 5 rupee coins were there? So firstly, let me associate this entire story with the total money we have. So the total money comes out to be, let's assume the quantities were x, x and x. Okay, so the total money that we have here is 10x is to 20x is to 10x. This means a total of 40x was there, and it was coming back in terms of 80 rupees. So that means the value of x was nothing but 80 upon 40, which is equal to 2. Now this 2 will help us get rid of the x that we chose in the beginning. So there is 5x, there is 4x, and there is 1x. 2 needs to be multiplied here. This is 10. 2 multiplied here. This is 8. And 2 multiplied here. This is 2. Okay. What does 5x associate to? It means it is a 2 rupee coin. What does 4x associate to? This means this is a 5 rupee coin. And what does 1x associate to? This means this is a 10 rupee coin. So if somebody asks you how many rupees 5 coins were present, so you would give the answer as there were 8 5 rupee coins. Okay, there were 8 5 rupee coins, and that is my answer. Moving ahead, in a wallet, there were coins of rupees 1, 2, and 5. I'll write them down quickly. 1, 2, and 5. This is the value. Okay. And the ratio has been given, or the quantity ratio has been given as 2 is to 5 is to 3. Okay. This is the ratio that has been given. If there are 54 in all, how many, if there is 54 rupees in all, then how many 5 rupees coins were there? Okay. So now my focus would be the 5 rupee coin. And the total money is 54. Okay. The total money is 54 rupee. This is an important point to focus on. Let me assume all of them to have a quantity of x. There is no need to assume it, but I'm still using it just because in this question, this is required. Okay. Then there is 2x, then there is 10x, and then there is 15x. This total comes out to be 27x, and the value of 27x is equal to 54, and the value of x is again 2. And the question is 5 rupee coins. 5 rupee coins are in the proportion of 3x, which is equal to 6 here. Okay. So there were 6 5 rupee coins. Again, it has been established that we are doing fine. Moving ahead. Now there is something called as ratio after x years. Let's assume that there is a ratio of a is to b, and because of a few years passing away, let's say y years passed away, the ratio changed to p is to q. When such a situation arises, there is a concept of cross multiplication which you need to apply. Okay, this cross multiplication was taught to students in class 8th. I'm pretty sure you must have forgotten it by now because it was difficult at that time to understand. So what happens is, whatever is dealt with in the lower side becomes the numerator. Whatever is dealt with on the higher side, this becomes our denominator. Okay, so this is the denominator and this is the numerator. In the numerator, this means py minus qy whole upon aq minus pb. Okay, need not remember this formula. Just remember that the lower portion becomes the numerator and the upper portion becomes the denominator. And that is how we'll be solving all such questions. Okay, so let's go. A is younger than B by 8 years. If 4 years ago their ages were in the ratio 1 is to 2, then what is the present age of B? It is said that A is younger than B. It means the value of A is equal to the value of B. A is younger than B. So if I'll add 8 years in the age of A, then only we'll be able to achieve the value of B. So this has been established and this is our first equation. Secondly, if 4 years ago their ages were in the ratio 1 is to 2, it means the ratio of A is to B is equal to 1 by 2 when we are talking about 4 years ago. This means that A minus 4 upon B minus 4. Okay, so A minus 4 and B minus 4. Then it's asking me the present age of B. This is our second equation. This is our second equation. 1 upon 2. So we have two equations and two variables. So once we solve it, we'll be able to find out the value of B. I'll immediately use the value of A from this equation and put it over here. The value of A is equal to B minus 8. So B minus 8 minus 4 whole upon B minus 4 is equal to 1 upon 2. So I'll take it there. This is 2b minus 24 is equal to b minus 4. This 24 would shift to the right and b would come here. So the value of b is equal to 24 plus 24 minus 4, which is equal to 20. So the present age of b is equal to 20. Okay, I hope we are sorted with that. Moving ahead. So this was nothing but two equations in which we applied the concept of ratio, simplified them, put them together, eliminated the value of a because it was not required in the answer, and focused only on b. So I'll move on to the next question. In this question, there is a good possibility that I can apply the cross multiplication the method, the one which I taught over here. Okay, I'll show you how I applied it. The present age of the father is twice that of his son. Okay, so this is the father and this is the son. Okay, 2 times of the son, 2 is to 1. Simple. Now 8.5 years hence, it means both of them grew by 8.5 years each. And this is a very natural phenomena. If time will go ahead, everybody would grow old. Okay, if time would move on, then everybody would grow. The ratio now became 7 is to 4. The reason for the ratio becoming 7 is to 4 was the passing of 8.5 years in the middle. So 7 and this would get cross multiplied, this and this would get cross multiplied. Whatever in this is at the top would become the denominator, whatever is at the bottom would become the numerator. Okay, so 2 fours are 8 and 7 ones are 7. So 8 minus 7 would become the denominator. Then 7 multiplied by 8.5 minus 4 multiplied by 8.5. Now 7 and 4 are being judged. So try to understand what's going on. The multiplication of 7 with 8.5 might be a little tricky. So let's take 8.5 common. 7 minus 4 is 3. Now 3 when multiplied by 8.5 is easier to do. Okay. Whole upon 8 minus 7 is 1. 3 8s are 24. 24 plus 1.5 is 25.5 years. Okay. So my answer is over here as the first one. And why did I come to this conclusion that the value of this portion is equal to 25.5? Because the value of 25.5 is equal to 1 unit. Okay. Had he asked me the value of the father's age, I would have to multiply it by 2. Why? I would have to multiply it by 2 because the father's age is 2 units and the son's age is 1 unit. The value which came out was that of 1 unit. That is why 25.5 could be marked. Got it? The value which came out was of 1 unit. And also, this 1 unit's value which has come out, this is only applicable to the first ratio. If you wish to apply this 25.5 and multiply it with the second ratio, it is not going to work. Okay, this value which comes out is only applicable to the first ratio. Okay, this is the most sorted method. This is the most sorted method to solve such questions. Okay, got it? So moving on to the next question. Now in this particular question, we would be solving fraction based problems. Yes, so now we are at concept number 8. The concept number 8 talks about fraction based ratio and proportion jobs. See, what usually would happen is that the fractions which we are going to deal with are definitely going to be two fractions side by side. Okay, AB upon CD, A upon B is equal to C upon D. So some operation would be done on A, some operation might be done on B, and then there might be an equation which comes out of it. So need not worry about it. All the methods that I haven't taught in the previous videos, they are going to be used over here. And simple proportion. What do I mean when I say the word proportion? Proportion. It basically means that the first operation, after doing a little bit of tweaking on it, then would be equal to the second operation. Okay, the two operations would be same. This is what literally the word proportion mean, and the meaning of the word proportion. Okay, so let me take you to the question directly. The denominator of a fraction is 4 more than twice the numerator. When the numerator is increased by 3 and the denominator is decreased by 3, the fraction becomes 2 by 3. So what is the difference between the denominator and the numerator of the original fraction? Okay, so let me assume that the original fraction is numerator upon denominator. The first equation that we can get out of this is that the denominator of a fraction is equal to 4 more than twice the numerator. The denominator is equal to 4 more than twice the numerator. When the numerator is increased by 3, when the numerator is increased by 3, this is the second equation. We've successfully found out the first equation. The second equation says that when the numerator is increased by 3, n plus 3, and the denominator is decreased by 3, d minus 3, then the fraction becomes 2 by 3. So we have two equations and two variables. It is very easy for us to reach the first point where numerator upon denominator was given, and it is easy for us to reach the fraction portion of it. Okay, so let's simply solve it out. I'm going to put d is equal to 4 plus 2n in the second equation. So 4 plus 2n, I'll be putting it here, n plus 3 upon 4 plus 2n would go in the denominator, minus 3 is equal to 2 by 3. From this equation, we can find out the value of n, the numerator. We can find out the value of n, the numerator. So let me go ahead about it. 3n plus 9 is equal to, this equation, I'll solve it here itself. It would be 1 plus 2n. Okay, this equation has been solved. When multiplied by 3, but when multiplied by 2 would give me 2 plus 4n. Okay, so when I take n over here, this becomes simply n, and the value of n when 2 goes here, this becomes 7. Becomes 7. Okay, so we found out the value of n as 7. Plugging in this value in the first equation, if the value of d is equal to 4 plus 2n, and I've already found out the value of n as 7, so this would be 4 plus 2 into 7. This would be solved first. This would be given as 18, and my numerator upon denominator would be coming as 7 upon 18. What is the difference between the denominator and the numerator of the original fraction? The value is 18 minus 7, which is nothing but equal to 11. Okay, so we are done with this question. Moving on. So I now have certain type of questions which are called the income and the expenditure questions. Okay, this is nothing but the income, and E stands for expenditure. Expenditure. See, what happens in certain kind of income and expenditure questions. I have already taught you the cross multiplication method. Okay, remember this, the present age of the father and the age of the son. I have taught you the cross multiplication method. Uh, so in this question as well, in the income and the expenditure method, the cross multiplication method would be used. Okay, the cross multiplication method would be used. I'll apply it, and then you'll be able to understand how I did it. Okay, I'll apply it and then you'll understand how I did it. The monthly incomes of A and B, this is the income and this is the expenditure. Monthly income of A and B are in the ratio 1 is to 2, and the monthly expenditure of them are in the ratio 1 is to 3. Now, income minus expenditure is equal to savings. Okay, income minus expenditure is equal to savings. And savings are already given in an absolute term. Okay, in an absolute term. What do I mean when I say absolute term? It means that it is not related to anything. If somebody comes and asks me what is the income of A, I can't say anything more than 1 is to 2 when it is compared by B. If somebody asks me what is the expenditure of B, if somebody asks me what is the expenditure of B, I can't say anything other than 1 is to 3 when it is related to B. But here in savings, I can easily say that each one of them are saving 4,000 rupees a month. 4,000 rupees a month. They are saving 4,000 rupees a month. So I need to find out what is the monthly income of B. Let me be very clear about this, that whenever we are using the cross multiplication method, the only outcome you can achieve is the first row. Okay, the only outcome which you can actually receive is just the first row, and there is a reason to it. The reason is that whenever we cross multiply, the unit which whatever unit comes out can only be applied to the first row. I'll tell you how. Let me do the cross multiplication. Whatever is under would go in the numerator, and whatever is above would go in the denominator. So 1 4s are 4,000. 4,000 minus 4,000 into 3 is 12,000. So it's nothing but 12,000 minus 4,000. Okay, this is the numerator of the fraction, and this is basically nothing but the unit. The unit. Okay, so 1 3 is a 3 and 2 1s are 2. So this is nothing but 3 minus 2. What I get out of it is 8,000. So 8,000 is the unit which I have received. Now this 8,000 unit, which is also equal to 8,000 rupees, can only and only be multiplied with the income of A and the income of B. It cannot go towards the expenditure side. So I'll do the same. I'll multiply 1 is to 2. This is A and B, and this is the income that I have, and 8,000 needs to be multiplied here. So the income of A is 8,000, and the monthly income of B is nothing but 8 into 2, that is 16,000. So here is my answer where I say the income of B is equal to 16,000 rupees. Okay, I hope I've made myself very, very clear how the cross multiplication method works and how I reach the unit point. And after reaching the unit point can only and only be applied to the first row, be it the income, be it the age, or be it whatever. It can only and only be applied to the first row. Okay, I hope I've made that very, very clear. Moving ahead, the income of, thank you. Yeah. So the income of A and B are in the ratio of 5 is to 4, and the income of B and C are in the ratio of 5 is to 6. What is the ratio of incomes of A is to C? This sort of a question we've already done. This sort of a question we've already done, and it is nothing but the same thing of shifting digits from here to there. Whenever we find ratios in such a format, this B would shift here and make it B here, this B would shift here and make it B here, and then we would have A multiplied by B, B multiplied by B, and B multiplied by C. So this is the same thing that we are going to apply over here. A and B are in the ratio of 5 is to 4. Okay, this is A, B, and this is B, C. And the income of B and C are in the ratio of 5 is to 6. So what I'll do is I'll shift 5 here from here to here, and then I'll shift 4 here from to the right hand side. So I'll multiply all of them. This is going to be 25 is to 20 is to 24. So 25 is to 20 is to 24. So what is the ratio between A and C? From this equation, I can easily see that the ratio between A and C, between A and C is 25 is to 24. Okay, it's 25 is to 24. I hope we are good. Okay, moving ahead. Um, Now we are going to solve questions where the income and the expenditure of one person is given. Okay, whenever the income and the expenditure of one person is given, in such cases you'll see you'll be only able to understand good things when you read the entire question. But what you'll be able to understand from the concept which is written here is that we are talking only about one person. There is some income, there is some expenditure, and if there is income and there is expenditure, then there is a great possibility that there would be savings as well. Okay, so this is nothing but expenditure and this is nothing but income. And one more thing, income is the largest part. Okay, income is the largest part. Out of the income, let's assume that this entire portion is spent. Okay, this entire portion is spent, so I can call it expenditure, and the portion which is left behind, this is called savings. Also, I can easily write the value of income is equal to expenditure plus savings. Okay, the value of income is expenditure plus savings. So I'll be moving ahead and solving the question for you. The ratio of the monthly income and expenditure of Dinesh is 17 is to 14, and his monthly savings are 12,000. If his monthly income is increased by 10,000, if his monthly income is increased by 10,000 and expenditure is decreased by 2,000, then the net ratio of his income and expenditure is what? Okay, so let me go ahead and solve it. Let's assume this is 17 and this is 14. This is the income. I'm not assuming it, I'm taking it directly from the question. This is the income and this is the expenditure. I have two things over here. Let, like, at the top of your head, if I tell you that the income is 17 rupees, at the top of my head, if I tell you that the income is 17 rupees and I also tell you that the expenditure is 14 rupees, then what would be the value of savings? What would be the value of savings? You would directly say it would be 3 rupees. You would directly say the value would be 3 rupees. So in such a case where you have the income, the expenditure and the savings, you can easily assume that this is nothing but 17x, this is nothing but 14x, and this is nothing but 3x. What is the reason? Could you tell me? Could you tell me what is the reason that I have introduced x in the equation? The reason is very simple. The reason of introducing x into the equation was that I don't have absolute terms. If you'll ask me what is the income of x, what is the income of Dinesh, I would simply be able to say 17x, 17 times something. So that is why a variable was required to be there, which is x. Okay, because everything is in ratio terms. I don't have the answer in absolute terms right now. The only absolute thing which I have in hand right now is 12,000 rupees, which are his savings. So accordingly, if the savings have come out to be 3x, then I can easily say that the monthly savings are 3x is equal to 12,000. I think nobody would be having any problem with this. So the value of 3x is equal to 12,000. So the value of x simply comes out to be 4,000 rupees. I hope we are good. I hope we are good. So the value of x is equal to 4,000 rupees. Now, let me directly take you to the income and the expenditure. If I have found out the value of x, I can plug them back in to the income and the expenditure. So 17 multiplied by 4,000 would give me the income, and in a very parallel way, the expenditure would come out if I multiply 14 by 4,000. 17 fours are 68, so this is 16,000 is the income, and 14 multiplied by 4,000, 14 multiplied by 4,000 is equal to 56,000. So I have the gap between 68,000 and 56,000, which is equal to 13,000. No, 12,000. But I won't be using it right now. But I won't be using it right now. if his monthly income increased by 10,000 rupees. His monthly income is increasing by 10,000 rupees. That means his monthly income gets a plus 10k short, which makes it 78,000 rupees. Then his expenditure is decreased by 2,000 rupees. That means his expenditure has gotten a cutoff minus 2,000, has gotten a cutoff minus 2k, which would give me the value as 54,000. 54,000. These are two different areas. Okay, these are two different values. So what am I going to do here now? The net ratio of his income and expenditure is required. This is the net change which has come up, or this is the net output which has come up. If somebody is going to ask me after the entire transaction, where am I sitting? So I would say that the income of Dinesh is 78,000 rupees and the expenditure of Dinesh is 54,000 rupees. Okay, so we are cool with this. We are cool with this 78,000 and 54,000. Let me quickly put it to ratio. Let me quickly put it to ratio to get my final answer. Okay, the three zeros go with the three zeros, and I think six nines are 54 and six thirteens are 78. So I have 13 is to 9 as my output, and the net ratio of his income and expenditure is nothing but 13 is to 9. Okay, I hope I made myself very, very clear. Moving ahead, the ratio of monthly income and expenditure of a man is 7 is to 3. If his expenditure is 5400 rupees, find his monthly income. Find his monthly income. The expenditure is 5400 rupees. This question seems to be pretty easy. I'll tell you why. The income has been given as 7, the expenditure has been given as 3. Okay, the income is given as 7 and the expenditure, yeah, so the income is 7 and the expenditure is 3. So I is to 3, I is to 3, I is to 3, I is to E. Okay, if his expenditure 5400, so the expenditure's value is already been given as 5400. Okay, and we're already talking about monthly incomes over here. So if the value of 3 is 5400, this means there is a factor of 1800 which has been multiplied. So similarly, if 7 is also multiplied by 1800, then I would be able to reach the income. So 7 8s are 56 and 126. 18 sevens are 126. So 126 and two zeros would come here. So finally, the income would come out to be 12600, and this is my output. Okay, this is my output. Moving ahead, when ratio of the income for the last year and the present year is given, let's assume that you were earning 4 rupees in the past and your friend was earning 5 rupees in the past. Now your income has grown by 4 is to 9 times and your friend's income has grown by 5 is to 7 times. So this new ratio of the present year and this ratio of the past year is given. See, this entire situation could be dealt with very easily. This entire equation could be dealt with very easily. And the reason was that the past and the present were directly related with the same number, because I told you that the ratio between the past and the present for A is 4 is to 9, and the ratio between the past and the present of B is 5 is to 7. That is why you could easily relate to it. This problem becomes big when I say that the past of A was 4, but the present of A is different. The past of A was 3 times and the present of A is 7 times. When this situation comes, you cannot directly assume that 3 is equal to 4. You cannot directly assume that 3 is equal to 4. You have to think a little more. You will have to equate the 3 with the 4, and then you'll also have to multiply the same thing which you multiplied by 3 to multiply it by 7. Okay, so this is the entire story. I hope so. This is very clear. Yeah, moving ahead. So now this is the real question that we were talking about. This is the real question which we were talking about. The ratio of the incomes of A and B in the last year was 4 is to 3. Okay, so this is A and this is B. The ratio between the incomes of A and B in the last year. So I'll say old and I would say new. Okay, old and new. Old versus new. So the old thing between A and B was 4 is to 3. The ratios of the individual incomes of the last year. I'll just change my pen color because this is now going to become a little vital. The ratios of the individual incomes from the last year and the present year. The ratio of the incomes, the ratio of the individual incomes of the last year and the present year is 3 is to 4. This is 3 is to 4 now. This is the ratio 3 is to 4 and 5 is to 6. 5 is to 6. 5 is to 6. If their total income in the present is 2412 lakhs, 24.12 lakhs, then the sum of their income in A in the last year and B in the present year is. I would like you to think about how I will proceed, and then within the next 30 seconds, I'll start the question. So, yes, I'm going to continue the question now. I'll be back with the red pen. Okay, I'll be back with the darker red pen. So, now if I'm supposed to compare the 4 with the new upcoming salary of A, what I'll be doing is the ratio is 3 is to 4 over here. If I multiply this 4 with another 3, so this is 3 4s are 12. This would come out to be 12. Now, the ratio between old of A and new of A is 3 is to 4. So, if 3 times 4 is equal to 12, then 4 times 4 would be equal to 16. 4 times 4 would be equal to 16. Also, if 3 was multiplied by A, then the ratio between 12 and 3, the ratio between 12 and 3, the ratio between 12 and 3 is not the same. We will have to multiply B with also the same number. We will have to multiply B with the same number as we did multiply A. We multiplied A by 3. We multiplied A by 3. So I'll multiply 3 with another 3. So this gives me 9. This gives me 9. So I have 12 is to 9. So here I'm satisfying three ratios. I'm satisfying three ratios. I'm satisfying three ratios. The first ratio is 12 is to 9, which is again equal to 4 is to 3. I'll write it again over here. Okay. I am satisfying three ratios. I am writing 12 is to 9. This is equal to 4 is to 3. And I'm also satisfying the new ratio, but only that of A. Okay. I'm only satisfying the new ratio, and that is only of A, which is 16. Now I think everything is very clear to you. Now I'll again bring my other concentration pen. The concentration pen means that you have to feel and you have to see the question a little more thoroughly, because whatever I'll be whatever I'll be teaching now, whatever I'll be teaching now will be a little like difficult, a little difficult for you to understand. So the ratio inside these own pockets between the old times and the new times is 5 is to 6. Okay. So the ratio between B's old times and B's new times is 5 is to 6. So this is pretty much clear. I will bring back my dark red pen. If 5 relates to 9, so I'll multiply 5 and 9, which gives me a 45. I should have gotten a much different pen. Let me take green this time. If 5 relates to 9, this should have been equal to 45. You agree with this? I hope yes. So if I'm supposed to keep the ratio of 5:6 intact, I will have to multiply this 9 over here and call it 9 6 54. Call it 9 6 54. Similarly, if 45 has come out to be B's old salary, because it was multiplied by the ratio 5, I would have to multiply A with 5 as well, which would give me A's old salary as 60. If A's old salary was 60, then he has to maintain a ratio between his old salary and his new salary. So I will multiply 16 as well with 5, and it would give me his new salary as 80. I'll come back to the point. Old, new, A is to B. When I say 60 over here and I say 45 over here, I say 80 over here, and I say 54 over here. Now, very, very carefully see what happened and where I've come. The ratio between A is to B was 4 is to 3. Has that been maintained? 15 4s are 60 and 15 3s are 45. So 4 is to 3 is very much evident. Good. So the ratio between the individual incomes of last year and the present year are 3 is to 4. 20 3s are 60 and 20 4s are 80. 20 3s are 60 and 20 4s are 80. And 5 is to 6. 9 5s are 45 and 9 6 are 54. So 5 is to 6 is also maintained. This only and only tells me, that the way I followed was correct, and you should also follow the same way. Now, these terms which I have with me, A is to B and A old is to B is to A old, A old is to A new and B old is to B new. These are again not absolute terms. These are still in ratio. Keep this in mind that they are still in ratio. Moving ahead to this point, that the total income of the present year is 2412. This means the new or the present year 80 plus 54, which is nothing but 134, relates to 24.12, or it is a proportion of 24.12. Then the sum of the income of A in the last year and that of B in the present year is, let me figure out what is the sum of A in the last year, which is equal to 60, and B in the present year is equal to 54. Now, what do I actually make out of it? The value of 134 has been given as 24.12. The value of 134 has been given as 24.12. But the value of 60 plus 54, the value of 60 plus 54 comes out to be 114. The value of 114 needs to be found out. So 24.12 was equal to 134. Now I need to find out the value of 114, which is available here. Let me quickly change the color of my pen. And this is not for concentration, but to help you figure out how big this calculation is and how easily you can actually solve it. Okay, simply going by 2. 2 5s are 10 and 2 7s are 14. Again, 2 6 are 12 and 2 7s are 14. Now there is a good possibility that 67 would be directly cancelled by 24.12. 67 would be directly cancelled by 241 point or 2412. 67 ones are 67. Okay, I play it big when it is required to play big. 67 ones are 67. Now, if I multiply 60 with 4, I get the value of 240. But I'm already sitting at 240, so I will not multiply it by 4, but I would rather multiply it by 3. Okay, 67 ones are and 67 threes are. This is going to be a little less than 240, maybe even pretty less than 240. It would be touching somewhere around 201. So if I am at 201, when would a situation come that the unit digit of 67's multiple is equal to 2? So 7 6 are 42. So the unit digit comes out to be 2. 67 ones are 67 and 67 6 are. Whatever comes in 6 is going to be my answer. So my final answer comes out to be 36 multiplied by 57. Now 36 when multiplied by 57. This is a little difficult calculation, but I would make it easier for you. When 36 is multiplied by 50, I get the value as 1800. Okay, 37 multiplied by 50 is 1800. Now I just need to multiply 7 with 36. When 7 is multiplied by 30, it gives me 210. And when 7 is multiplied by 6, it gives me 42. Now I need to add all of them up. The value would come out to be 2, 5, and a 0 maybe. Yes, yeah, 2052. So my final output would be 20.52 lakhs. 20.52 lakhs. Okay, 20.52 lakhs. I hope I'm good. I hope we are good with that. Okay, moving to the next question. The ratio in proportion when A is to B is increased or decreased, and we need to find out the new ratio. Okay, let me take you forward with it. In an examination, the success to failure ratio was 5 is to 2. 5 is to 2. Okay, this is the success means plus, failure means cross. Okay, success to failure ratio was 5 is to 2. Add the number of failures, okay, been 14 more. Then the success to failure ratio should have been 9 is to 5. Should have been 9 is to 5. The success to failure ratio should have been 5 is to 5 and 9 is to 5. This is the first situation and this is the second situation. What people usually tell you, what people usually tell you is to equate the successes so as to get a very clear picture of the failures. But I would tell you to use the cross multiplication method one more time. Okay, use the cross multiplication method one more time. But you'd ask me, there was no change in the successes. How can I use cross multiplication? So my answer is the change in the successes was nothing but 0. Okay, the change in the successes was nothing but 0. So when this situation occurs, you put a 0 over here and still solve the question. Whatever is in the numerator, whatever is down goes to the denominator, and whatever is up goes to the denominator. So 9 multiplied by 14, 9 multiplied by 14, and you can say plus 0 or minus 0 because 0 multiplied by 5, it is basically 0 minus 0 into 5 whole upon 5 5s are 25 minus 9 2s are 18. So this is what I get. 9 into 14 whole upon 7. 9 into 14 whole upon 7. This I have 7 ones are 7 and 7 twos are 14. So 9 twos are 18. And 18 is nothing but not my final answer. 18 is not my final answer. 18 is nothing but the unit. Okay, 18 is nothing but the unit. Okay, I hope you get that very very well, that 18 is the unit. Now this 18 can be applied to anywhere, to 5 or to 7. The total number of candidates who appeared for the examination was, if I add up 5 and 7, that would be the total number of students who appeared for the examination. But this is not an absolute number. You will have to multiply the unit with it. So 7 into 18 would give me the value 126. Would give me the value 126. And 7 into 18 would give me the value of 126. 7 into 18 would give me the value of 126, and which would be the total number of candidates who appeared for the examination. Okay, total number of candidates who appeared for the examination, 7 into 18. I hope I made myself very very clear in this video, in this particular question. Whenever you're doing a cross multiplication and you find out that one of the leg is missing, then instead of leaving the question behind, it would be so much better if you could it would be so much better if you could put simply a 0 over here and continue solving your question. But remember, 18 or the unit which I found out was not the final answer. You have to use the unit back with the first situation. Okay, you have to use the unit back with the first situation. and the unit can only and only be multiplied with the first situation only. You cannot use the unit with the second situation. You cannot use the unit with the second situation. All right. All right. Moving ahead. Okay. So in a school, there are total of 414 students. The ratio of boys and girls is 5 is to 4. If 46 more boys get admitted to into the school, then what will be the new ratio of boys and girls? Okay. There are a total of 414 students. The ratio of boys and girls is given as 5 is to 4. Okay. This is boys. These are boys. These are girls. 5 is to 4. Now, our sorry, our cross multiplication thing would not be valid, and our cross multiplication thing would not be applied over here. I'll tell you why. I'll simply tell you why. Because b is to g is 5 is to 4, and the total of this is already given as 414. Okay. The total of this, the total of this is already given as 414. 5 is to 4, 5 plus 4 is equal to 9. So the value of 9 has already been given as 414. Okay. I'll quickly use it. I'll quickly use it. The value of 1 unit is equal to 414 upon 9. 9 4s are 36 and 9 6 are 54. So the value of 1 unit is equal to 46. 46 what? 46 students. Okay. The value of 1 unit is equal to 46 students. When I say 46 students, why do I call them students and not boys and girls? Because we haven't segregated them on any basis right now. If I multiply 5 by 46, I would get the total number of boys. If I multiply 4 with 46, I would get the total number of girls. So 46 is the unit. If 46 more boys get admitted into the school, then what would be the new ratio of boys is to girls? See, I have the value of 1 unit as 46. When it says that 46 more boys are entering, then I can say that plus 1 unit of boys are entering. When I say plus 1 unit of boys are entering, then I can easily say that the current ratio of boys is to girls is equal to 5 is to 4. This is a very sharp point, which I'm telling you. This is a very sharp point. If I have B is to G is 5 is to 4 and 1 unit gets added in the boys, this means plus 1. The ratio comes out to be 6 is to 4, which in turn comes out to be 3 is to 2, which in turn comes out to be 3 is to 2. So I've made myself very clear. I've made myself very clear that the new ratio of boys is to girls is equal to 3 is to 2. If you want to take it the longer way, I'll tell you how to use that. The longer way says that 1 unit boys need to be added. Let me find out the total number of boys first. 5 multiplied by 46 would be the total number of boys, which would come out to be 230. Okay, these are boys. Talking about girls, 4 multiplied by 46, this would come out to be 4 6 are 24, 4 4 are 16, 184. Now, plus 46. This means plus 46 more boys are getting in. This means 230 plus 46 would be my new ratio or the new number of boys. This would give me the number as 276 is to 184. 276 is to 184. Now, let me cut it off. 4 6 are 24. 4 9s are 36. 4 4 4 4 4s are 16. And 4 6 are 24. Another time, 23 2s are and 23 3s are. So 3 is to 2. We're back to the same ratio. We are back to the same ratio where we started. Okay. So I have B is to G. So 6 is to 4. 6 is to 4. 6 is to 4. Okay. So we are coming back to the same point. We are coming back to the same point. Okay. I hope we are doing good. Okay. I hope we are doing good over here. Moving ahead. Now there can be issues, or there can be situations where A is to B is to C, and 1 upon A is to 1 upon B is to 1 upon C is considered. Okay. So what I have already taught you about 1 upon A is to 1 upon B is to 1 upon C. If I wish to bring all of them to the numerator, if I wish to bring all of them to the numerator, what I would do is I would say B multiplied by C is A multiplied by C is to A multiplied by B. Okay. B into C, A is to C, and A is to B. So this is my way of solving questions. This is my way of solving questions. And everybody else also, I think, solves it the same way. They take the LCM and then take it to the numerator multiplied by all of them, and they get the same output as this. And then there is a comparison between A is to B is to C. Okay. Then they compare the two terms, that A got this, but in the new times, A got this. Okay. B got this in the old times, and B now got A into C. So this is an entire comparison which would be following you throughout the times. Okay. Moving ahead. By mistake, instead of dividing 702 among Ram, Ramesh, and Naresh. Okay, there is Ram, there is Ramesh, and there is Naresh. Okay, there's Ram, there is Ramesh, and there is Naresh. So it was divided uh, in the ratio. This is, see, I'll tell you about the wrong ratio first. Okay, the wrong ratio first and the right ratio. The ratio which, instead of dividing it, okay, so instead of division means the real ratio, the wrong ratio was 3 is to 4 is to 6. The correct ratio which was expected, the correct ratio which was expected was 1 by 3 is to 1 by 4 is to 1 by 6. Okay. 1 by 3, 1 by 4, and 1 by 6. Okay. So let me quickly figure out how to solve 1 by 3, 1 by 4, and 1 by 6. As I've already told you, the method would be taking the LCM or simply multiplying 4 into 6, that is 24. Then 3 into 6 is 18, and 3 into 4 is 12. Using 6 common, 6 fours are 12, 6 threes are 18, and 6 twos are 12. So the correct ratio, the correct ratio was uh, the correct ratio, the correct ratio was 4 is to 3 is to 2. The wrong ratio was 3 is to 4 is to 6. Now, as the damage was already done, as the damage was already done, so the money was split in the wrong ratio. The money was split in the wrong ratio. I'm not using 702 right now. I am not using 702 right now. I will bring it sometime in the future. I will bring it sometime in the future. What is the addition of 4 plus 3 plus 2? This is equal to 9. And what is the addition of 6 plus 4 plus 3? This is equal to 13. To make the ratios seem equal, I would have to multiply 13 with 9, and I have to multiply 9 with 13. So this entire equation gets multiplied by 13. The value of the correct side. Okay, I'll rewrite it for you. There is a correct side and there is a wrong side. The value of the correct side comes out to be 13 fours are 52, 13 threes are 39, 13 twos are 26. Now 9 would be multiplied. 9 threes are 27, 9 fours are 36, and 9 six are 54. 9 6 are 54. Okay. So the correct and the wrong one. But the wrong one was actually followed. The wrong side was actually followed. And because of that, because the wrong side being followed, there was somebody who made gains. Okay. Because of the wrong side being followed, there was somebody who made gains. Now I need to find out who was that somebody. Okay. This is Ram, this is Ramesh, and this is Naresh. Out of these three, who do you find to have actually made some gains? See, loss. Okay, there's a big loss. There's a loss of 3. But only this guy made gains. Okay, only this guy made gains. And by how much? That is what I have to find out. That is what I have to find out. Instead of getting 26 rupees, this guy got 54 rupees. Okay, instead of getting 26 units, I would rather say this guy actually got 54 units. And what was 702 divided into? 702 was originally equal to um 13 into 9, which is equal to 117. Okay, 13 into 9, which is 117. The money, which the gap which I see over here between 26 and 54 is that of 28. Okay, is that of 28. This would give me by how much, the money was gained. Okay, so let me follow it. I'll use a table of 9. Why am I using the table of 9? Because 702, the sum of the digits is 9, and the sum of the digits 7 plus 1 plus 1 is also 9. So 9 6 no 9 sevens are 9 eights are no 9 sevens are 63. Then another 72, 9 eights are 72. 9 ones are 9, and 9 threes are 27. 13 ones are 13, 6 is 78. So I have 28 multiplied by 6. I have 28 multiplied by 6. Now 6 8s are 48. I have 4. I have 4. 6 2s are 12. 12 plus 4. 12 plus 4 is 16. Okay. So 168. This outcome which I have now is the amount of money that was gained by Naresh because of the wrong transaction, or because of the wrong ratio. Okay. Because of the wrong ratio, he gained 168 rupees more. I did not find how much was the correct money. I did not find how much was the wrong money. I just found out the gain, which was 28 units, and I found out the value of 28 units in this particular question. Okay, moving ahead. A certain sum was to be divided between A and B in the ratio of 8 is to 5. However, by mistake, it was divided in the ratio 5 is to 8. Thus, A gets rupees 300 less than his original share. Okay. Okay, so A gets 200, 300 rupees less than his original share. So try to figure out what I'm talking. 8 is to 5 was the correct one, and 8 is to 5 was the correct one, and by mistake the wrong one was 5 is to 8. The sum of 8 plus 5 is 13 here. The sum of 5 plus 8 is also 13 here. This means I need not equate the ratios together. I need not equate the ratios together at any cost. So if I'm not equating the ratios together, what am I actually doing? I am considering that they actually had 8 rupees and 5 rupees with them, and they actually had 5 rupees and 8 rupees over here. Okay, so this is A and this is B. Now A is getting 300 rupees less. A is getting 300 rupees less. So this 300 rupee less, which we are talking about, is equal to 3 units. This 3 units is equal to 300 rupees. Okay, this 3 units is equal to 300 rupees. Now I need to find out his original share. His less than his original share. Yeah. So find the sum. Now I need to find out what is the sum that was actually used. The sum all the time was equal to 13 units. As I already know, the value of 3 units is equal to 300. The value of 3 units, the value of 3 units is equal to 300. The value of 13 units is equal to 1300 rupees. Okay, this was a rupee sign. This was also a rupee sign. So my final outcome comes out to be 1300 rupees. Okay, my final outcome comes out to be 1300 rupees. And that is my final point. Moving on. Now, there is a concept of branched ratio. What happens in branched ratio is that out of, let's say, a sum of 20 people, let's say out of a sum of 20 people, 10 of them were boys and 10 of them were girls. Okay, this is boys and these are girls. These are boys and these are girls. Out of those boys, let's say 4 of them wore socks. 4 of them wore socks. So we have that 4 of them are wearing socks and 6 of them are bare feet. Okay, bare feet. And then 3 of the girls are wearing socks and 7 of them are bare feet. So this is how the concept of branch ratio works, that you have a big ratio over here and then you get into, then you go down to the next level. And after going down to the next level, but because here the thing in comparison was the gender, the thing in comparison was the gender, and here the thing in comparison was socks or not. Okay, what is the gender, and if socks are gonna be there or not. So I think this really clears my point, that socks or not versus gender. When you have multiple parameters arising out of a single source. You have multiple parameters arising out of a single source. That is when you call it a branch ratio. And see, the figure of a tree is like this, that you start from here. This is the main branch. This is the main branch, or let's say the trunk, and then the branches go up. Okay, this is nothing but a tree ratio or a tree format. On the other hand, when I talk about a branch format, what happens is the branch is hanging by the tree and the branch is itself splitting itself into multiple areas. So this is a branch format where a center point is splitting itself into multiple areas with the help of parameters which are not related. Okay, the gender is not related to socks, but the socks are related to bare feet, and a girl is related to a boy on the basis of gender. Okay, so I hope I've made myself very clear what branch ratio actually means. I'll be taking you directly to the question now. In a school, 5 out of 12 of the number of students are girls and the rest are boys. 4 of the 7 of the number of boys are below 14 years of age, and 2 of 5 of the number of girls are 14 years or above 14 years of age. If the number of students below 14 years of age is 1120, then the total number of students in the school is what? Okay, so let me start off directly by 5 upon 12. When I say 5 of 12, this means that my starting point was 12. So I would make a bubble over here. Okay, and the bubble says 12. So what is it? The 12 is the total students. This is the total number of students. So the first branching is on the basis of gender, about boys and girls. 5 of 12 are girls. So this means very clearly 7 of 12 are boys. The first branching has been successfully done. 4 of 7 of the boys are 14 years and above. Out of 7 boys, 4 are minus 14. Minus 14 means less than 14 years of age. This also means that 3 are 14 plus or 14 years of age and above. And secondly, 2 out of the 5 girls are 14 years or above. If I'm denoting 14 plus over here and I'm denoting 14 minus over here, okay, 14 plus 14 minus or minus 14, this sounds the same. So 2 of the 5 girls, 2 of the 5 girls are above 14 years of age. So this is 2. And 14 minus this comes out to be 3. I'm doing nothing. If you move up the branch or if you move up the tree, you would see that 4 plus 3 is equal to 7, and for 3 plus 2 is equal to 5, and 7 plus 5 is equal to 12. This means that my ratios are very well placed. This clearly means that my ratios are very well placed. Okay. Now, the total number of students in the school is what? Yeah. So the total number of students needs to be found out when the number of students below 14 years of age. I'll just change the color of my pen. Total number of students in the school, and below 14 years of age. Below 14 years of age. This is one below 14, and this is another below 14. So this means 7 students out of a total 12 students are below 14 years of age. Then the total number of students in the school is what? If 7 is relating to 1120, this means there is a multiplication that needs to be done. 7 ones are 7, 7 6 are 42, and 160. Now, 12 would also be multiplied by 160. So when I multiply 12 with 160, what do I get? 12 6 are 72, and 12 ones are 12. 19, 19, 12 6 are 72, and 12 1920. This says that 1920 is the total number of students in the school. Okay, this gives me the total number of students in the school. All right, moving ahead. In a party hall, there are people in blue and red dresses. The ratio of the number of men in blue dress to the number of women in red dress is 3 is to 7. This ratio of men in red to the number of women in blue is 2 is to 1. If the ratio of the number of people in blue to the number of people in red is 35 is to 76, then what is the ratio of the number of men to the number of women? Okay, number of men to the number of women. This means that we are talking about branch ratios. So there are men and there are women. Okay, and we are talking about dresses. Okay, we're talking about dresses. The dresses are blue or red. Similarly, the dresses are blue or red for women as well. The ratio of number of men in blue to the women in red is 3 is to 7. The men in blue to the women in red is 3 is to 7. This means this is 3x and red is 7x. Why am I introducing a variable x so early? There is a reason to it, and you'll get to know about it in the next sentence. This ratio of men in red to the number of women in blue is 2 is to 1. See, the men in blue and the women in red are different from the from the men in red and the women in blue. These are two distinct ratios and they cannot be compared right away. When such a situation arises, you have to assume that there are two different variables that are being compared. That is why the men in red is to the women in blue is equal to 2y is to 1y. Okay, because if you'd like to compare the number of women and the number of men now, you can't just say 3 plus 2 is 5, 5 plus 8 is equal to 13. You can't come to the conclusion that 13 is the total number of people, because there is a method to it. And what is the method? You'll get to know right now. If the ratio of the number of people in blue to the number of people in red, let me add up the number of people in blue, which is equal to 3x plus 1y, and the same ratio is to the number of people in red, which is 2y is to 7x, or 7x plus 2y is equal to 35 is to 76. It is 35 is to 76. Now, what is the ratio of number of men to the number of women? When I find out what is the value of 3x plus 2y, and I find out what is the value of 1y plus 7x, that is when I find out what is the total number of men and what is the total number of women. Okay, so let me quickly first solve this, and then I would move towards finding out the ratio between men and women. So look at it now. 76 threes are 3 6 are 18, 3 7 are 21, 228x plus 78y is equal to 35 sevens are 7 sevens are 49, 49 fives are 250, 245. So 245x plus 70y. Okay, so from here I can say that when 228 goes away, I get 12 plus 5 17. this is 17x, and then there is 8y. So I get x is to y is to is equal to 8 by 17. Now I need to find out the ratio, the sum of total men. I cannot find out the absolute value of men because throughout the question you did not find even a single place where the number of men is written. You always found things in ratios. So x is equal to 8 as in ratio, y is equal to 17 as in ratio. I will plug in the values and find out my answer. The number of men is equal to 3x means 24 plus 2y is equal to 34. This is nothing but 58, and the number of women is equal to 7x. 7x means 56 plus 1y is equal to 17. This makes it 63 and 73. So I get the total ratio of number of men to the number of women to be 58 is to 73. 58 is to 73. I understand that you did not get the answer over here, but I believe my answer to be correct. What I would do now, I would quickly recalculate whatever has been going on. Okay, you please be with me. The ratio to the number of men in blue to the number of women in red is equal to 3 is to 7. Yes, 3x, 7x. Similarly, the ratio of men in red to the women in blue is equal to 2 is to 1. 3x plus 1y is equal to 7x is equal to 7x plus 2y. This whole is equal to 35 over 76. Okay, 3 6 are 18 and 3 7 are 21, 22. 2 to 8x. Then we have 78y. Yes, we have 78. 7. This is not 78y. This is 76y. This is 6y. Okay, this was the mistake that was made. Okay, this is 6y. So the value of this comes out to be 6 is to 17. Okay, through these mistakes only you get to learn where you went wrong. Hmm. So only this portion needs to be corrected. This is 6y, this is 6x and 17y. So I need to find out the value of 3x plus 2y. 3x means 18, 2y means 34. This means 42 plus 10, 52. And women, on the other hand, is equal to 7x means 7 6 42 plus 17. 6 makes it 59. So my final answer is 52 is to 59. Apologies for the last mistake, and I don't count it to be a mistake. Why? Because we caught it. Okay, we caught it in the right time. Okay, we are good to go, and D is the correct answer. Moving on. When x gets added or subtracted to get proportional numbers. See, what happens is when two numbers, these are not yet in proportion unless something is added or subtracted from it. Plus minus x plus minus y, right? Plus minus x plus minus x. Okay, when such a situation arises that the plus minus thing comes up and you have to do it on all the variables in the ratio, that is when you get this concept number 13. What I'll do is I won't be solving it right away. I will be taking you to the next point first. Okay, these are much more important, but I would still let you take this question number 13 to be a test for yourself. Okay, take a screenshot of it and solve it without even me teaching you about it. Coming to concept number 14. Okay, concept number 14. Concept number 14 talks about proportions. So there are multiple kinds of proportions. There is mean proportion, there is third proportion, and there is fourth proportion. In mean proportion, you need to find out the value of x, which is equal to root a into b. When two numbers a and b are there, and it said that find out the mean proportion of it, then you need to find out the value of x. Whenever there is a situation when three numbers are in proportion, or the third proportion needs to be found out, so a comma b is to c is there, then the value of x needs to be found out. And see, I'll tell you how this x needs to be found out. There are three numbers, a is to b is to c. A upon b is equal to b upon c. One of the numbers out of the three would definitely be missing, and the value of AC would be nothing but equal to AC is equal to B square. Okay, AC is equal to B square. Whenever there is a concept of fourth proportion, if there are four numbers in fourth proportion, then the value would simply come out to be A upon B is equal to C upon D. Okay, mean proportion means root, third proportion means b square is equal to ac. The center element is equal to the square of the center element is equal to the multiplication of the corner two elements. And the fourth proportion means a by b is equal to c by d. Okay, this is the basic, or the most basic form of proportion is the fourth proportion. Okay, moving on. What is the mean proportion between 20 and 50? Okay, the mean proportion between a number is x, and 20 is nothing but 50. So this mean proportion is fixed 50. This means there is a square root over here. The square root, when transferred on the other side, becomes a square, which makes it 2500 immediately. So x into 20 is 2500, and I cut it off. The 0 is gone with 0, and 250 is 125. So the value of x is nothing but 125. See how easy this was. Moving to the next question. What is the mean proportion between this and this? So I'll quickly take a root. I would take 0.08 here multiplied by 0.32 here. When I have 0.08 and 0.32, I'll quickly remove the decimals and put 100 multiplied by 100 over here, and I would put the root on the entire question. If there are two hundreds in the base, that means one of them can go out, and 1 upon 100 is outside. When there is 8 and 32 over here, you can complicate the matter more by multiplying 8 and 32. But what I'll do is, out of it, if I bring 2 here, this makes 64, and as I've already taken 2 over here, this makes it 4. So 4, the square root of 4 is 2, and the square root of 64 is 8. So 2 multiplied by 8 upon 100, this gives me the answer as 0.16, and this is my final outcome. Okay, this is the mean proportion of the two numbers. Third proportion, as I've already talked about. Let me quickly solve the third proportions for you. What is the third proportion of 4 and 28? This means there is a third proportion which is c, or let's call it x over here. So the proportion comes out to be 4 upon 28 is equal to 28 upon x. 4 ones are 4, 4 sevens are 28, 7 eights are 56, 7 twos are 14, 196. So the value of x is nothing but 196. What is the third proportional? Okay, what is the third proportional? Whenever such a question comes up, you have to write a, b, and c together. And as I've already said, b is equal to ac. Any one of the number can be missing. This time c was missing. Okay, that is why it was said. What is the third proportional of 4 and 28? I'll be moving on. 180y and y is 24. If y is greater than 0, find the value of y. Okay, find the value of y. I can easily see that yes, this can take us to some place. This means 180 upon y and y whole upon 245. This is a question of third proportions only, and I need to find out the value of y. Y goes to y square, and then 180 is multiplied by 245. Okay, let me quickly put them out for prime factorization, and let me find out some things which are useful for me. There is a 5 available over here, and there is a 36 available over here. Simple. 36 is a square of 6, and 5, we'll figure out how to accommodate 5. There's a 5 available over here. Then we have 5 fours are 20 and 5 nines are 45. Okay. So we found out the couple of 5, we found out the couplet of 5, and we found out the value of 49, which is the square root of 49, which is 7. Out of the two fives I have here, I have 5 again. Okay. I have 5 here, 6 here, and 7 here. Now I need to find out the value of y. The value of y is nothing but 5 into 6 into 7. This makes it 7 5 is 35, 35 6 are 210, or simply 5 6 are 30, 37 are 210. Okay, the value is nothing but 210. Okay, and I'm good to go. Moving to the next concept, the fourth proportion, as I've already talked about. There are numbers in A is to B is to C is to D, and all of them would follow up this line: A by B is equal to C by D. What is the fourth proportion of 7, 15, and 21? So this means 7, 15, 21, and x. I need to find out the value of x. 7 ones are 7, 7 threes are 21, 3 into 15 is 45. So the value of x is nothing but, the value of x is nothing but 45. Again, we are good to go. Moving ahead. Similarly, there's a fourth proportion question here. 3 by 8 is equal to x upon 12. 4 twos are 8, 4 threes are 12, 3 threes are 9, 9 by 2 is the value of x. Okay, I did nothing, I did simple cross multiplication. Simple cross multiplication. I hope everyone is with me here. Okay, now there can be situations when a long question is written. Okay, a long question is written where you're not sure about how to manage things. Okay, I'll tell you how to manage that. There are three numbers to the ratio 3 is to 2 is to 5. B says that the sum of the squares, this could have been cubes as well. Okay, don't shy away from the fact that this could be cubes as well. When cubes come, need not worry, it's easy. Okay, I would rather say it is easier. 3 is to 2 is to 5. The sum of the squares is equal to 1862. Which number is the middle one? Okay, I will assume that this is 3x, 2x, and 5x. When I square all of them, they come out to be 9x square plus 4x square plus 25x square. Okay, 29 plus 8 is 38x square. This is equal to 1862. Okay, I think I should use the table of 19 directly. 19 2 is a 38, 19 9s are 171. When I have 171, there is a 152 also coming along. So 19 8s are 152. Okay, so 2 1s are and 2 49s are. So the value of x is nothing but 7. When the value of x is 7, then we have already assumed that there were three numbers a, b, c, which were 3x, 2x, and 5x. So I can quickly use this value of x and multiply it by 2 and call it 2x, which is equal to 14. And this is my outcome. The middle number is 14. All right, moving on. Three positive numbers are in the proportion of 2 is to 3 is to 5. If the sum of the squares is 342, find the largest number. This time it is 2x, 3x, and 5x. I'll call it 4x square plus 9x square plus 25x square. Okay, these are all the options. 25 plus 4 is 29. This is again 38x square is equal to 342. 38 ones are 38 nines are. Okay, so the value of x is nothing but 3. The largest number would be equal to 5x, and 5 when multiplied by 3 would give me the value 15. Okay, we are again good to go. Moving on. There can be cases when something is inversely proportional to the other number. Let's say that a is inversely proportional to b, or b is inversely proportional to a. In such situations, you are only able to find out the proportion. If you wish to reach the absolute value, you need to assume. We were assuming x all along in the past. Here we will assume that there is a constant k. Okay, we will call this beautiful thing a constant. K is a constant which will replace the sign of proportionality. What do I mean? If I wish to remove the sign of A is inversely proportional to B, I can write that A is equal to K upon B, or A is equal to K multiplied by 1 upon B. Okay, this 1 upon B is the same concept which we were talking about, and K is the new constant which was introduced. Okay, it is the constant, new constant which was introduced. Okay, we are good. Moving on. X is directly proportional to the square of y. This means x directly proportional to y square. When the value of x is 12, then the value of y. Okay, I'll just firstly take you to this point where x is equal to ky square. Now it's saying that when the value of x is equal to 12, then k is as it is, and y takes up the value of 2. Then find out what is the value of k. Okay, so 12 upon 4 is equal to k. 4 ones are 4 threes are. The value of k is nothing but 3. As I found out the value of k, I can easily say that the value of x is equal to 3y square. Okay, the value of k x is equal to 3y square. Now, as this equation is established, I can find out all absolute values. All absolute values can be found out. These, because of this proportionality signs, you could only find values which are surrounded by ratios. You would only get values depending on the other number. When the sign of equality has come, this means you will be able to find out the exact or the absolute values. Find the value of x when the value of y is equal to 3. Okay, so this means x needs to be found out when the value of y is equal to 3, and the square has to be done as well. So this means 3 multiplied by 3 square, so 9 3s are 27, which would be my final answer. Okay, again we are good to go. A is proportional to B, B is inversely proportional to C, and C is proportional to D. Then what is the relation between A and D? Just kind of see what's going on here. A is proportional to B, B is proportional to 1 by C, and C is proportional to D. This is not D, this is D. Okay, C is proportional to D. Now see how we are taking things forward. A is proportional to B, right? A is equal to KB, B is equal to L upon C, and C is equal to KLM MD. Okay, let me put the value of B as A upon K. The value of B is equal to A upon K is equal to L upon C. Let me put the value of C. Let me put the value of C as MD. A upon K is equal to L upon MD. Now, let me take it here. The value of A is equal to L upon M multiplied by K multiplied by 1 upon D. As the question is only asking us to be friends with A and D, what we would do here is we would consider this entire portion to be a constant. If you would see very closely, K, L and M, K, L and M, they were already constants in the question. They are just brought together. They are just brought together in the last equation. So I can easily say that A is equal to a constant, let's say x whole upon D, or I can also say that A is proportional to D in an inverse manner. So A is equal to 1 upon D is the real way of figuring it out. Okay, A is proportional to 1 upon D, or A is inversely proportional to D. That is how I went through. This is the end And let me come back to the point where I left you. Yep. Okay. So now I'll be taking to you through the question where A, where all the main proportions. I'll just get back here. Okay. All the main proportions which are A, B, C, and D need to be operated upon. Okay. These proportions need to be operated on so as to reach a point where they are in proportion. When I say that, let's say 1 by 2 is equal to 3 by, I should rather say 2 by 5, 2 by 5. If a 2 is added here, no, I won't be able to make a question out of it, out of like right off the bat, but I'll take you to the question directly. If x is subtracted from each of 24 is to 40 is to 33 is to 57. So minus x, minus x, minus x, and minus x. After after reaching a point where I am able to subtract minus x from it, after reaching a point, after reaching a point where I'm able to subtract minus x from it, that is when the proportion comes into the picture. That is when the proportion comes into the picture. 24 minus x, 40 minus x, 33 minus x, and 57 minus x. So there are steps to solve it. Okay. The first step being I need to find out the difference. I'll call them A, B, and C, D. A, B, C, and D. Okay. I'll call them A, B, C, and D. I need to find out the difference between A and B, and I have to divide it by the difference between C and D. And the difference which I would get, and there would be a division sign, I would call this M by N. Okay, I would call it M by N. Now the difference between A and B is nothing but 16, and this needs to be in absolute terms. Okay, there is a mod, which means that there is no negative or positive sign. It has to be a positive sign only. Okay, we have 16 here, and then we have a 4 and a 2 here, 24. So 8 2 is a 16 and 8 3 is a 24. So the value of M is to N is equal to 2 is to 3. The value of M is to N is equal to 2 is to 3. Now, as we found out the value of M is to N, there is a step, and the step is step 2. The value of X would be immediately available to you if you find out the difference between A multiplied by N minus C multiplied by M whole upon M minus N. Okay, so what is A multiplied by N? 24 into 3, that is 72, minus C, that is 33 multiplied by 2 whole upon 3 minus 2. Okay, so this brings me to 72 minus 66 whole upon 1 is equal to 6 upon 1. And this immediately brings me to the point where 6 is available to me. This brings me immediately to the point where 6 is available to me, and the value of 6 is equal to x. Okay, the value of 6 is equal to x. Now that I found out the value of x, the ratio of 5x plus 12 to 4x plus 15 needs to be found out. This means 5x plus 12 whole upon 4x plus 15 needs to be found out. 5x means 30. 30 plus 12 is 42. Okay. 4x plus 15. 4, 6 are 24. 24 plus 15 is 39. Okay. So this makes it 42 upon 39. This gives me 14 upon 13, which is my final ratio. This brings us to the end of the chapter of ratios, and I have solved pretty much all the questions. Okay, I've solved pretty much all the questions. I'll quickly take you through a very quick recap. I won't take more than 4 or 5 minutes to explain all the main concepts that I've taught you about ratios. Okay, the first one, that the like quantities need to be like quantities need to be compared with like quantities. Okay, and the inverse relations that I've already talked about. Moving on, the ratios are dependent on each other. They are not absolute values. You need to find out a unit value which needs to be multiplied. You need to find out a unit value which needs to be multiplied so as to reach the absolute value. Okay, then whenever you find this stacked ratios, a is to b, b is to c, then you need to bring all of them together and you need to shift the cornermost elements. Okay, there can be a situation where you find out ratios as a is to b, b is to c, and c is to d. Okay, at that time you have to shift c 2 times, b once, c one more time, and b 2 times. Okay, then you can multiply all of them vertically. When you have multiple ratios in this sequence. Okay, yep, then I've talked about inverse ratios. These inverse ratios are available to you. At that time, how do you convert all of them to, how do you get to the numerators only? Okay, check that. Further, the compound ratios, I've already talked about compound ratios. Compound ratios are nothing but multiplication of ratios. Okay, compound ratios are nothing but multiplication of ratios. Then componendo and dividendo, this was one of the most important things. In componendo and dividendo, what do I do is that I have such a ratio available with me. And I do an x plus y whole upon x minus y is equal to a plus b whole upon a minus b. Good. Then I do some cross multiplication. This is again cross multiplication, and this was more of componendo and dividendo. Okay, I used componendo and dividendo over here. Moving ahead, when a number is divided into 3 different parts, I have already talked about it. LCM needs to be taken whenever inverse ratios are there. So yep, I think we are good to go. Shifting I've already explained. These are again shifting. Then again shifting, I've already explained the shifting in 3 variables. Further, a is to b is to c is to d. Again, a bigger shifting. Again shifting. Yep. So I've talked about coins, how coins are distributed. The values need to be multiplied by quantity so as to reach a point. The values need to be multiplied by the quantity so as to reach a value which is equal to the final value of the coins. Okay. Same questions going on. Then this was the cross multiplication method which I introduced. This was the cross multiplication method. This was the cross multiplication method which I introduced, and it was used in multiple areas. I think I've covered pretty much all of it. Okay. I've talked about proportions, and cross multiplication method is used everywhere. Incomes and expenditure questions also can be easily solved with the help of cross multiplication. All age related questions also can be solved with the help of cross multiplication. I think we've covered almost everything, and this was today's lecture. Thank you so much for being there.